वाली नासा ह्यूमन एक्सप्लोरेशन रोवर चैलेंज 2021 में भाग लेने के लिए ओडिशा के नवोन्मेष प्रसार स्टूडेंट एस्ट्रोनॉमी टीम यानी कि नैपसैट के 10 स्कूली छात्रों को चुना गया है। आपको बता दें कि नवोन्मेष प्रसार फाउंडेशन की एक पहल नैपसैट जो कि भुवनेश्वर में है। नैपसैट अंतरिक्ष में रुचि रखने वाले लोगों की एक टीम है जो विभिन्न अंतर्राष्ट्रीय कार्यक्रमों में भाग लेने के लिए अंतरिक्ष प्रणालियों, रोवर्स, रॉकेट्स, उपग्रह और खगोल विज्ञान के डिजाइन को समझने और जानने में लगे हुए हैं। आइए नवोन्मेष प्रसार फाउंडेशन के फाउंडर अनिल प्रधान से ही समझते हैं कि नासा ह्यूमन एक्सप्लोरेशन रोवर चैलेंज 2021 क्या है, इसमें किन स्टूडेंट्स को चुना गया है और ये स्टूडेंट्स नासा के इस चैलेंज में क्या करने वाले हैं।
A student member of Team NAPSAT, Navonmesh Prasar Student Astronomy Team. Very grateful to coordinate on this auspicious day. Thank you everyone and my team. Today we have Mr. Satyanarayanan Chakravarthy sir with us. Thank you sir for giving your time for us. Mr. Satya Chakravarthy is the co-founder and technical lead at the ePlane company. He is also the co-founder and advisor at Agnikul Cosmos, Aerostrovilos and Extrofuels. He is also the founder and head of NCCRD, National Center for Combustion Research and Development, Chennai. Mr. Satya sir also is a mentor at Avishkar Hyperloop and an amazing aerospace engineering professor at IIT Madras. He did his doctorate in philosophy and PhD in aerospace engineering from Georgia Institute of Technology and his BTech from IIT Madras. He is a fervent of the deep tech entrepreneurship to reunify technology and glow in an era of defrastructure, an idea which dares the use of huge groundworks for economic hike with a spear based on exponential technology which fosters sustainable development. He has been awarded the Hindustan Aeronautics Limited Hall Prize in 1991 and Downey Hemsey ACRHEM Award in 2009. He has also been honored with the DRDO Academic Excellence Award in 2016. Really a great pleasure to meet you, sir. We are looking forward to what you speak. Thank you, sir.
Thank you very much, Varshini. Let me share my screen and start my talk. I'm pretty happy to be with you people. Very inspiring set of students here. Are you able to see my screen?
Yes, sir.
Yes, sir, it is visible.
Sure. Yeah, so I thought I'll actually talk about space technology and entrepreneurship. I think judging by the introduction that you just listened to, you can clearly see that I'm trying to see if technology can be utilized for entrepreneurship, and that is pretty useful for young people like you to seriously consider at some point in your life, not too late from where you are today. So I believe this may be quite useful to you. If you have to actually look at the space tech value chain, it starts with having to put some objects in space, and that's by means of a launch vehicle. So we need to have launch vehicles that are developed, and then the launches themselves are a service that is offered by whoever either builds a launch vehicle or somebody else who could just pick up a launch vehicle from somebody else and then just carry out the launch activity. So in India, for example, if you look at what ISRO does, ISRO is both. It develops its own launch vehicles, it makes its launch vehicles, and it also operates the launch vehicles and launches satellites. And in fact, it makes its own satellites as well, and so on. So when you now have the satellites go into orbit, they need to be tracked, and you need to transact with the satellites, no matter how deep into space they go, like if they go to the moon or go to Mars or any of those places. You need to have a ground segment which transacts with the satellite in receiving data as well as issuing commands and so on. And many of these satellites are used for several different applications. Communications is one very commonly used application, and the next one is remote sensing. And depending upon these applications, the orbits chosen will be different. The an emerging set of very unconventional applications that are also coming up, where you could be looking at data storage in space, or what's called as edge computing in space, and so on. So a lot of those kinds of applications are also coming up. Material crystal growth in space, material manufacturing in space, all of these things are also gaining some traction. While you get the data, so you can now, once you get the data, then what you do with the data is do a lot of data processing. This could be typically remote sensing. It's like very hugely data heavy. You get a lot of images, and you can then apply a lot of image processing techniques in order to filter out the data that you're looking for, and so on. And then of course you can also, these days you can do machine learning, deep learning of these images, so that there is some intelligence that you can gather out of these images by feature recognition and all of those things. So you get some insights, and then you now push those into different applications. There are also a growing set of downstream users called external developers, who actually take the data that's available and start using it for other applications than what was originally intended. So this is the whole value chain, and in this entire business, actually the launch part is a much smaller part when compared to a lot of other things. It's far easier to make satellites and get them launched into orbit. It's relatively easier to set up ground stations to communicate with satellites. It's relatively easy to do data processing and all of that stuff. So a lot of activity is in this part of the right-hand side part of the picture, very less on the left-hand side part of the picture. There are only very few launch vehicle companies that are around. We will focus in this talk on small satellites, and that is because it's much easier to actually make small satellites when compared to large satellites. So I'm trying to pep you up on what is relatively easier to do and still will make a big impact. So you could actually use the small satellites for communication. So there is a shift that's happening between what used to be the case with very large satellites being launched to what is now happening, which is like a constellation of small satellites. So it is not as if like everybody is shrinking their satellites, but they are breaking the satellite into multiple satellites and launching. There are several advantages for doing this. First of all, it's more like risk mitigation. If one big satellite is launched from one big rocket and that launch fails, then you've lost a lot. Whereas if you are looking at a constellation, you'll always have a large number of satellites that are doing the job for you. And if one or two launches go wrong and one or two satellites fail to get to the orbit, it's okay. You still have a system that is robustly building up altogether. That is like one major advantage. But from an application point of view, for example, if you're looking at things like remote sensing or even communication for that matter, you have what's called as frequent revisit times. So you can get, if you have large number of satellites that are orbiting, you can have some satellite or the other always looking at you. And then, of course, there is a handover from one satellite to the other, a baton passing, if you will, of the control on which satellite exactly is imaging or communicating with you at any point in time. But you now have these coming up in very quick succession. So this allows for us to monitor events rather than just places. So previously we used to simply say, well, we got this image, like Google Earth image, right? So for example, if you now look at Google Earth, that would be an image that was taken like maybe 6 months back, right? Whereas if you want to monitor an activity or so like for example, cyclone mapping, many times we get images only once in 24 hours. Whereas if it's possible for us to actually get very, very frequent as of satellites that are they get at the same time. I have been calling as and espousing as defrastructure. It'll all of a sudden it'll now allow for a large number of teams to make their satellites and launch when it's very clear that small satellites are useful just as well as large satellites are. So the mental block about doing these things by anybody actually just comes down, and a lot of people can get started doing these things. So that said, there are specific applications like zero gravity drug extraction, entertainment from space, data storage is something that I had mentioned previously. So this is an emerging market, and there is a lot of satellite subsystems testing, and IoT. All of that stuff is also happening alongside this, so that this is a huge sector that is emerging. Now, what is the problem with having to launch small satellites today, right? So if you now look at the payload fairing, as they say, right, the nose cone area within which the satellite is to be placed. So this is the size of the Ariane 5 payload fairing. This is the shape and size of the Falcon 9 payload fairing. This is GSLV, and this is the PSLV. Now, in all these things, we can see that a small satellite like the one that OneWeb of Bharti Airtel and so on, they are launching, right? This is just about 263 mm by 414 mm. It's only about this big, if you think about it, right? You can hold it in your hand, sort of. That will be like a speck or a dot in the entire payload fairing. So, on the other hand, the kind of satellites that they launch will occupy an entire huge hall with very, very high ceiling. That's the kind of satellites. They are much bigger than a human being, right? So, for example, you can clearly see that these payload fairings are of the order of, like, let's say this is 13,900 millimeters, right? So that's of the order of about 13 meters tall, right? So whereas a human being is typically only about let's say 1.8 maximum, right? So this is like even 10 times more than, like close to 10 times taller than a human being, right? Or more than that. So that's the level of huge satellites that they are used to carry. So if you want to get one of these launch vehicles to carry a small satellite like this is kind of like expecting a passenger wanting an entire train to be running just for himself, and that's completely infeasible, right? So what happens then is there is a forced rideshare that happens. That means that you want to go from place A to place B being some particular location in orbit. Place A is like some launch pad on Earth, right? So you want to go to a particular place, a particular orbit, particular inclination, and orbit insertion, and all of that. But this is kind of like taking a bus, right? So that means like you have to go to the bus stop and you have to actually catch the bus that comes, share the ride with a lot of other passengers, and it'll stop you, it'll put you at some bus stop, and then from there you have to go to where you want, and so on. Whereas what we are actually talking about is it possible to actually have an Uber or an Ola for satellites? That means like somebody wants to launch from somewhere, we should be able to take a rocket to them and put made the satellite to the rocket and then launch it from there to the place that they want the satellite to go to, right? So because and we know that, for example, in a bus ride there is a waiting time and then you have to share space. So in this picture you can clearly see that this is a PSLV nose cone, and this is the Cartosat satellite. That's a huge satellite, right? And they have now accommodated a lot of small satellites. You can see how small these satellites are when compared to, they are just small boxes when compared to the big satellite that you have. These small satellites will have to wait for an opportunity for the payload bay to get filled up with a lot of satellites, which essentially means that what should I say? There is a waiting time involved in this. So many times it's actually possible to build a satellite in about 6 months, but you may have to wait for as long as 2 years, which is significant. So what kind of delays are actually caused for small satellite launches is that you have about 34% launch problems is because of lack of launch on demand vehicles. So many of these problems that we have are primarily because you don't really have what's called as launch on demand vehicles. And 40% of the launch problems are actually due to ride sharing. So one of the things that will happen is like, let's say you have the cartosat that has to be launched, and that is the primary payload for that particular launch. And all the small satellites, they will have to comply with certain standards that are to be enforced on the small satellite developers because there is a cartosat, and the cartosat should not get affected because you have the small satellite. So they will put a huge premium on the kind of standards that you have to follow for building your satellite. Whereas if you were to just launch by yourself, there is nothing that is interfering with your satellite. So you may not really want to be up to that standard. You might just get a satellite that simply works, and it may not be the best in the world, but that's fine. But it works, and that's what you want to get up there, right? And that could actually decrease the cost significantly when compared to having to meet the standards for a ride share with a large payload, because there are insurance costs and all of that stuff. So the big satellite owner will be bothered if a small satellite is going to affect its performance, and so all of those interferences make for a lot of delays and so on. So effectively, 75% of all launches are delayed due to today's launch services construct, and which is essentially based on large rockets, right? So how big is this problem? This is actually a significantly huge problem. There are two columns here that we have. So the first one is the mass, like we talked about 100 kg class, right? So satellites are typically measured in terms of kg class. So if you now look at communication, Earth imaging, other applications, IoT, subsystems testing, science and research, space situational awareness, all of that, there are a lot of these different customers that are involved in developing these kinds of satellites. And cumulatively, each of them has like about 49 tons, 39 tons, and all of that, totally up to about 100 tons worth of small satellites getting developed. And if you look at, in turn, the revenue potential, once a satellite is launched, because a satellite will stay up there for about 5 years, beaming images that can be utilized downstream for lots of commercial applications and so on, there's close to about $4 billion worth of commercial activity at stake, because we are delaying by 2-3 years for getting these things launched with large satellites. Similarly, you can also look at the growth of it. So the previous slide showed you what is the current status, but this also actually gives you the growth potential. And year on year, even with the presence of only the large rockets and this ride share being forced and all of that stuff, you can clearly see that satellites have been accumulating and getting launched more and more over the years, and the future potential is expected to actually grow almost like exponentially, right? So there is a 50 to 20% growth cumulatively that is expected over the years through, like, let's say 2024. And when you now say, and I think we saw this in the previous slide, the 100 tons and the 4 billion number by 2025. So who are all the players in these in the small satellite category, or even large satellites? Let's put all of them together. We can see that less than 250 kgs, we have a few of them, like Agnikul, Astra, Orbex, Rocket Lab. If it is 250 to 1000 kgs, there are a bunch of those, which are like Skyrora, PL Space, Glamour, Gilmore, Firefly, Skyroot. Skyroot is an Indian one, and ISRO, of course, is there. And then greater than 1000, ISRO is also there, SpaceX, Relativity Space, Ariane Space, all of these. Right, so this is approximately the play field of different launch players for different rocket, different satellite categories in terms of mass. The interesting thing about this market is you have what's called as a negative working capital, which means that by the time you are actually launching, you have already got about 95% of the money. So many times, one problem that exists in these big operations is who's going to put the money first to get the rocket, and then you get the satellite launch, and then you will have to get the money, right? If that is the case, nobody will be able to do that. So what happens in this business is that the satellite makers are aware that there is a risk of launch, risk of launch failure. In spite of that, they get it covered through insurance, and they pay upfront for the rocket development or the rocket construction, right from maybe about some 6 months before, right? And then they go through this entire cycle where they do a down payment of in installments all the way. In fact, it's 24 months. I'm sorry, made a mistake, right? So at launch minus 24 months, you already have got about 40% of money, and by about launch minus 7 months, you are actually getting up to 95% of the money. And at launch is when you actually get 5% of the money. So this is actually a very good situation for an entrepreneur because you get a lot of capital upfront, and that's very, very useful when compared to having to put in money and then try to recover it. Right now, the other interesting thing is there are about 77 launch ports that are available for orbital and suborbital launches. What we are trying to do at Agnikul is to even break free of these classifications, that we don't necessarily have to worry about the availability of an existing launch port with its infrastructure. We want to be able to actually launch out of even a barren land. And I will tell you how we are planning to do this. That's again a infrastructure feature. So there are. So if you now look at what is upcoming launches that are going to happen in 2021, 2022, you can watch for these. And we are expecting that from 2022 onwards, some of these things could actually even happen with Agnikul, right? In fact, all these things are supposed to happen with Agnikul. Even 2021, we do a suborbital a launch, and this one is all orbital launches. Is what is expected. And this is a crowded slide with a bunch of charts, but I think the most important thing to look at is what's highlighted over here. So you can see that there is like a large amount of investment that's been happening, and the kind of investment change that's happening year on year is like 26%, 67%, right, and so on. So these are actually showing that the amount of money that is getting plowed into this space is very, very significant. So there is also a very important thing that's happened in the last 6 months, I would say from April or May. The Indian government has actually announced the formation of something called InSpace that allows for ISRO to support space startups in developing their launch vehicles and satellites or any space technology that ISRO already has. It's not like they will actually do a transfer of technology, but they will handhold you, they will support you with facilities for testing, even allow for launch pad access, all of that stuff, right? So this is a huge step. And one more thing that I would like to point out here, I think I've made this point in some of my LinkedIn posts before. The government actually has very few levers on technology development directly. Space is one of them. Nuclear science, atomic energy, that is another, and third one is defense. So atomic energy and defense are sort of like critical technologies. They cannot just share that with anybody. But space is something that's useful purposes. Of course, they have a regulation on any misuse, against any misuse. But otherwise, space is actually available for everybody to start developing technologies on. And that's the reason why ISRO has been selected for it to utilize, offer its facilities and expertise to be utilized by private players, could be startups mostly. And then what happens is you will see, like the very fact that you have actually called me to talk is because I'm part of Agnikul and you would like to hear about it and so on, and you want to learn more. So over time, when you now have more of these Agnikuls kind of thing happen on the startup space, people will start wondering, particularly young minds will actually start wondering, hey, if actually a team can make rockets and launch, why can't we make cars, scooters, trucks, lots of other things, or it doesn't have to be anything moving, it could be stationary devices. So it will spur a lot of motivation for people to do a lot of hard technologies. And hard technologies lead to hardware products, and these are high-tech items which have a huge value. And this is how we have like large number of people developing many of these novel high-tech products and sell them within the country as well as abroad, right? That's how the GDP of the country grows. So you see that starting from one small push on the space front over here, we expect that this will actually foray into something very huge in the next few years to, let's say, the next decade or so, for India to really have this young generation, really shore up and do something great. That's exactly the expectation out of this. So, having said this, let me just talk about Agnikul in specific, right? And you will probably get a feel for what we are and what we do, right? So, Agnikul Cosmos was founded on the idea of that getting to space should not be the hardest part of being a spacefaring species, right? So, there must be a quick access, affordable access to space with a launch on demand approach. So that is kind of like the Uberola, the Uberization of space, if you will. So we target a 100 kg payload to start with. Towards the end of the presentation, I will say how the 100 kg could actually become more. But more importantly and interestingly, this 100 kg could also become less. And that's more important and more difficult. If you now make a rocket to take a particular mass, how do you actually reconfigure that rocket to take something less is what we are being more concerned with. And I'll show you something about that, right? So just as a quick aside, the word Agnikul basically is something that roughly or very loosely translates to a place where people learn to use fire, right? So the kul part is coming from the Gurukul, and Agni is fire, right? So we are a 4-member core team. Srinath and Moin are the entrepreneurs over here, and Dr. Perumal and myself are the advisors, right? So we have about 60 people working here, and there is an advisory board of about 10 ex-ISRO scientists, as well as some present ISRO scientists that ISRO has identified for us to use work with. Right. So just to give you a sense of scale, right? So if you now look at the SpaceX's Falcon 9, when compared to the SpaceX's Falcon 9, the Agnikul's Agnibaan, the first product that we want to take 100 kgs of payload to low Earth orbits, is just about that size. You can see, right? There's a scale version. It's about 1/30th the cost and 1/4 the size. And so, I mean, one would have expected if it's 1/4 the size, we should have actually be 1/4 the cost. And that is actually a strength of coming out of India. So India has certain very unique advantages here that I would like to highlight, right? Just like how you guys are, going to NASA and all that. So there are a large number of middle class people who are interested in technology, science, learning, and with the STEM series and so on. That's actually a very, very large number. So we have a large pool of people who are technically very well qualified, and yet the average income per person, if you now see, it's actually not is very low by world standards. So we have been able to actually develop things extremely frugally coming out of India, and that's a huge strength that we have to. Now, 10 years back, 20 years back, we would have probably known for doing some very small software like data entry operations or something like that on one side, or maybe do textiles and so on. We are not technically extremely deep, but here we are actually talking about making rockets, right? So this is like we can do some very, very technically deep stuff as well at very, very low cost, right? And that's a combination that is a killer. It can actually penetrate across the world and get us to the top. And Agnikul will be one of those examples that actually showcases this prospect. So our main motto here is launch where you want and pay for what you launch. Okay, so we had this slogan, Agnikul, Agnikul with a tagline of launch anywhere, anytime, affordably. So anywhere, anytime. And affordably, all three of them have actually been metricized. As in, what is the metric by which we can say anywhere? What is the metric by saying anytime? And what is the metric by which we can say affordably, right? So all these three are actually being worked on with the kind of business case that we have. So the launch, this is launched from a mobile launchpad, as they do very large intercontinental ballistic missiles. Which essentially means that all we need is essentially a barren land and a socket to plug in for getting the power source somewhere, in the barren land, and we are good to go. We can actually set up our own launch pad on the go and just launch from there without any previous infrastructure except for power supply. So, and then the pay for what you launch, I will tell you in the next few slides. The vehicle actually can be tailored to a particular payload down to a certain level. So the launch cost on $1 per kg basis remains almost flat over a very large range of payload masses. Now go back to this thing picture that we had before, where we saw a OneWeb Bharti Airtel satellite as a very small stub, right, in all of these payload fairings. The same is actually going to look like this when you now explode, which means that we are occupying significantly a large amount of the payload fairing here. That means that the entire payload fairing can take this small satellite and fly without having to wait for any other satellite to be put in there and stuff, right? So this is the primary what's called the product market fit. The most interesting thing about Agnikul is this fully 3D printed single piece engine. So what was actually about like 1,000 different parts to assemble has actually simply become one part. And this is something that no other launch vehicle company or organization has been up to. And this has also been made possible because we are actually starting with small satellites and small launchers. 3D printing today is actually happening over a certain build volume, which is approximately this kind of a size. In which case, can we fully make use of what is the current 3D printing capability and configure a rocket for that, right? So this is something that we had to think about 2 years back in order to get to this point of being able to show a completely fully 3D printed engine, which has like hundreds of cooling channels, 70 plus plumbing passages, right? 8 different injector elements in this case. So the bigger version that's going to be used in the first stage will also be a fully 3D printed version, which we are planning to 3D print in the next couple of months, and we'll probably be able to share photographs of that on social media and so on. Just watch out for it. There, you will have like some 40 plus injector elements, and each of these injector elements is extremely complicated. And it has like narrow passages and artifacts like counter swirl and coaxial passages. And in reality, you would have had to assemble those pieces intricately and then assemble in turn them in the injector plate and so on. So all of that assembly is just completely eliminated over here with this. Now, this also means that we can do launch when you want. So previously, in the couple of slides back, we said that launch where you want and pay for what you launch. There is a third part, which is launch anytime, which means that you can also do launch when you want. So the idea here is when you now bring the satellite, we can actually start printing rockets, assemble them, and launch your satellite in about a week's time from when you brought your satellite. So that is just about the waiting time that you need to give, and I wouldn't have to worry about making a rocket and waiting for a satellite to come, right? So it becomes very good for both the satellite maker and the launch vehicle maker. So here we have the National Center for Combustion R&D that I have founded and headed, where we have like significantly large amount of facilities, and that's what is actually being used, like laser diagnostics or test rigs and so on, where we have been able to establish the Agnikul's engine testing facility as well. And let's say the bottom picture shows the phase Doppler laser particle size analyzer for testing sprays out of these injectors and all of that. So this picture, this slide actually shows that flat cost curve that we talked about, pay for what you launch. So if you now look at the current market price on how this launch per cost per kg happens, if you're actually having a payload mass of about 100 kgs, the current going rate is of the order of about, let us say, $30,000 per kg. That means that 30,000 into 100 is what you will actually end up paying, right? This works out fairly cheaper if you now get this curve to go further out of this picture, up to let's say 1000 kg payloads and all those things will be far still cheaper. It will come down to something like about 20,000. This is actually, of course, also flattening. So it will come down to something like about $20,000 per kg for large satellites. That is the current going rate. The moment you try to bring this smaller, what it essentially means is that the same rocket is actually being used for a smaller satellite. So the entire expenditure is the same, but on a per kg basis, the satellite maker has to pay more, and that is why the curve keeps going up and up and up as you keep going down in the payload mass. What we are doing is we have a modular rocket approach. So the 3D printed picture that we showed in the previous slide is actually one of these rockets. And in the first stage, we can start all the way with about 7 engines in the Agnibaan, and then bring it down to 6 and 5 and 4. And for different payload classes, we can actually have different configurations, as well as put the right amount of propellant for the different orbits that we have to go to, so that the entire cost actually can be managed in a much flatter cost curve down to about 30 kgs. Even if it is actually even 10 kgs, we are lesser than the market. That is one thing, but the gap is less. But the gap is significant if you can actually see, over here, right? So 30 kg class, if you have a 30 kg payload, Agnikul will probably be the cheapest you will ever find in the entire planet, right? The launch where you want part is where we actually put it on a mobile launch pedestal. And this means that all we have to do is to pack the rocket in a container truck, and you can now ship these containers on ships to different shores and get them to be wheeled to different places, the launch sites nearby, and you can actually launch, right? So this means that we can pick and choose different locations that are very appropriate for that particular orbit that you want to go to, whether it's an equatorial launch, which means that we are close to the equator, or if you are a polar launch, we want to be close to the pole, and so on, right? And there is no landmass that is inhabited by people in between for when the launch debris will have to fall, right? All of that stuff can be eliminated if we have this. So we have, I think you must have seen news reports that we have signed an agreement with Alaska Aerospace for launching out of Alaska. And similarly, there are lots of other places that we have been talking to. Of course, our first launch we expect is to happen from Shar, because we are an Indian launch company, and we will be very happy to actually work with ISRO, because they will take care of our safety requirements and make sure that we are secure, all of that stuff. And so we'll get the benefit out of ISRO's oversight and guidance. And there is also a legal obligation according to international law that the country of the company is the one that is has the sovereign obligation if there is any problem, right? So if we go and actually cause damage to any other property in any other country, it's the Indian government that will actually be liable. So considering that, I think our first launches will be out of Shar, and then we will have to make forays into other launch areas. But as I said, it's just a matter of actually getting a barren land instead of having any specific infrastructure. So there are some pictures of the hardware that is completed, that is happening. We have started doing tests out of this. We have developed a composite overwrap pressure vessel for very lightweight tanking, and so on. So this basically shows how we are different, not very important to go through. I think I have highlighted some of these already, so I will probably skip this. And this shows a comparison with a few other vehicles like Astra, Orbex, and Rocket Labs, which are within the 250 kg capacity. And you can see, of course, a bunch of greens over here on the different metrics where Agnikul scores over other people. Okay, you must have heard about Agnikul in many places, and so this is just compiling that. Yeah, I think this is probably the last slide where what we can do further beyond 2025. 2024, 2025 is to actually make bigger vehicles, and that's not very difficult, because all you have to do is to strap on the first stage itself multiple times over. Like have 2 strap-ons, you can go to higher payloads. You can have 4 strap-ons and go to still higher payloads, and so on. So so as I said, going bigger is to simply grow the vehicle. But once you make a particular vehicle, it's much harder to shave off that vehicle to take smaller payloads and charge about the same rate. And that's what we have actually factored in. So what we will get is somewhere between 30 kgs to about something like 300 kgs or even 600 kgs payload. That's a wide class of payloads over which the cost will remain pretty much the same on a per kg basis. That's a huge technological advancement and what do you call advantage that Agnikul's modularity basically offers. I think that's about all I have. So this is a good time to stop and maybe take questions for the remaining time. Right.
Yeah, so sir, the presentation was totally awesome. We got to learn a lot of things about Agnikul. So yeah, I'll start with some questions. So my first question is, sir, about the Agnibaan, as you said, means Agnibaan is already a very cheap launch vehicle to space, and means you might have seen that recently Rocket Lab tested their first stage to be reused, the sender back to the sender. So are you also planning to do something like that in future?
Yes, indeed. Of course. The thing is, what we are going to do is again take advantage of the fact that we are a small rocket and not do the way SpaceX does their reusability. So, I mean, we have to understand that rockets themselves are actually a huge brute force machine, right? So if you look at it, it's actually like a pencil-shaped vehicle, and we're pushing it from the bottom, right? So any small tilt here and there has to be corrected very quickly, and it has to be staying vertical when you want to push. And one of the reasons by which this is actually accomplished is to give a huge push so that even before it tilts significantly, it goes to space. So a rocket is a very, very brute force approach to going to space. First of all, let's keep that in mind. On top of it, the way SpaceX does is to actually get this pencil back with pushing it from below, right? That means that there is so much amount of guidance and control power that is required for you to do, and there is so much amount of propellant that is being spent in making that happen. And that means you have to carry that propellant along with you while going. That means you are taking less payload because you are taking some propellant for coming back, right? So they have done a cost benefit analysis on does it make sense for me to save this rocket for the next launch versus can I take more payload, right? So what we do is our approach is different, and I will not reveal exactly what that approach is today, but we will not do this at all, right? We will not go through this brute force. So we will not take any extra propellant for coming back, right? That means like we will be able to spend the entire energy available for taking a payload and take as much payload as possible, but we will be able to reuse. And we have plans for doing that in a much more milder manner than the way they have done, right? And that will be hugely cost effective, and we will be even more cheaper than what I have shown you, right? Because when we reuse, right? This is one part of the story. The second part of the story is we have plans for launching from a higher altitude. So if you just try to go up to about 10,000 meters or 20,000, 10 kilometers or 10, 20 kilometers and launch. So for example, if you look at the PSLV's first stage, right, it does two things. The first stage essentially does two things to the vehicle. One, it takes the rest of the vehicle up to about 30 kilometers before it burns out. And it of course imparts a huge velocity to the vehicle for it to go further out. Okay. Now, if I am able to actually manage these, not maybe 30 kilometers and the kind of velocity that that you reach, but let's say I go up to about 20 kilometers, right, and then impart some velocity, right, my rocket size will come down significantly. So whatever rocket size that you saw for the Agnibaan when compared to the SpaceX, it will be much smaller than that, and I will further be able to recover that also, right? Which means that I will be spending like much less for going to space when compared to what Elon Musk does, basically, right? So we will just shatter all the records. That's the expectation that we have.
Okay, yes, sir. So actually, I wanted to ask a question.
Please.
What is the exact concept of defrastructure? Like you said that Agnikul can use barren lands, as the they can use barren lands for the the
Launch vehicle for launching. Yeah. Yeah.
sorry, yeah, launch as launch ports. Yes, sir, the launch
Yes.
ports. So
Correct.
Agnikul can use barren lands as launch ports, and you said that defrastructure is a concept related to it. So I wanted to know more about that.
So what you will find as India is becoming more and more closer to a developed country, right? So we are still a developing country, and we have been hearing that we have been a developing country ever since we know, and that's been like that, right? So what is the problem with this being a developing country, and when will we actually become developed, right? So one metric people actually use is GDP per capita. That means on a per person basis, what is the GDP, right? That is called GNI, gross national income. So that is like GDP divided by the population. Since the population is very high, what we will find is the denominator is very large, and therefore the GNI is always going to be small. And for a very long time, because of the total population, we will always be classified as what's called as a middle income country. And we have actually moved from a poor country to a middle income country because our GDP has grown to something like close to $3 trillion today. All right. But the population also has grown. And therefore, we will always be classified as this middle income country for a very long time. All right. But that is not to say that we are not tasting the pleasures. For a large amount of this population is actually middle class, and they are tasting the benefits of technology that pretty much as let's say somebody in America does, right? So you'll have pretty much the same kind of smartphones, or your refrigerators, or cars, or whatever a typical average middle class American enjoys is also actually available to us, right? So we think that okay, fine, my gross national income is less because there are a lot of poor people also, but most of the people, we are not very rich, but we are not too poor either, right? So we are middle class, right? So we can actually be classified just as well as anybody else, like in Western Europe, or so why are we still kind of like developing, right? So the answer to that is the other part, which is what kind of infrastructure do you have? Do you have like large number of highways? Do you have all these huge flyovers crisscrossing each other? Do you have very large airports? Do you have very large seaports? Do you have very large launch ports? What about your electricity grid, right? And so all of these things, the Western world through the 20th century has done in massive scale, so that it will actually bring them the benefit of economy of scale. So only when they had these technologies in the previous century, with which, like for example, it's not just that, right? So like for example, sewer lines in cities, drainage lines in cities, water pipelines, gas pipelines, right? All of these are infrastructure items. So if you now look at, for example, I don't know what is the situation in Bhubaneswar as far as drinking water is concerned, but in Chennai, for example, we get drinking water by having our own water filters at home. Okay, or we have drinking water in these cans, right? So we get like these 25-liter cans, or a 2-liter bottle. That is infrastructure. That means we are not really dependent on the government to give us a. I mean, if you go to Europe or US, you can actually open the tap from in the kitchen or even the bathroom, right? And then drink out of it. It's a potable water. They have taken a lot of effort to get a potable drinking water to your bathroom or kitchen, right? Whereas we have tried to do the same thing in a completely different way. The government does only some amount of water supply, and from water supply, there are a lot of bottling companies that will actually purify a little bit more and then sell it at a cost. If that cost is affordable to you, right? For example, the shampoo sachet, that's a infrastructure. A poor person may not actually be able to buy a bottle of shampoo, but they can buy that ₹1 shampoo sachet for let's say once a week bath, right? So that kind of thing is actually ingrained in our psyche. How do you now translate that into technology, right? Is it possible for us to generate our own power in the backyard with whatever facilities that we have? Is it really necessary that you need to have drainage and sewage systems, right? So similarly, do we have to depend on the government for launching satellites? Is it possible for a community to say, let's say, for example, a village panchayat, to decide that I want a satellite to be looking at my village's crops to figure out whether my crop yield can be improved, and I get like real-time data and so on, and they are willing to spend an X amount of money for that, right? If they have to do that today, they will have to depend on the state government, and the state government will have to tell the central government, all of that stuff. It's too complicated, right? That will get into a huge infrastructure item. Whereas if they now decide, no, I think we just want to do it by ourselves, come to Agnikul, right? We will launch a satellite, right? And what do we launch out of? Just give me a barren land. I don't need a huge launch port, Sriharikota, and all of that. So how do we just completely, cut all the clutter and then get to the point and do things in a small scale, right? It's not exactly small scale. It is like small gadgets that are easy to build by even a group of students, right? But you now actually have to make it a product so that you are able to make large number of that to make the impact at the same scale as one big item so this is the whole idea of infrastructure. That means like we are essentially challenging the notion that that has been prevailing, that you need to have government spend massive amounts on infrastructure for the country's development to happen. Instead, we say now people themselves can actually develop these technologies as small products, but make large numbers of those and distribute among themselves without much government involvement, so that we will develop our economy and our comforts and whatever, right? All the marks of a developed country is possible to do without all these big infrastructure. That's the idea.
Okay, sir. So we have one of our viewer who wants to ask a question. So his first question is, what is the power of the first stage engine? I guess he wants to ask in terms of kilonewton, how much thrust the first stage can produce.
I think it's 140 kilonewton.
Yeah. Then the next question is, sir, what if the satellite provider wants the orbit 0 degree from the equator?
What about that?
Means how you're gonna launch that if the satellite provider wants
yeah,
0 degree inclination?
You're saying like you have to go to the equator then, right? So you have to go to the equator and launch in the same equatorial plane, right?
Okay.
So so that's why we could actually find locations along the equator. I think I showed in the map a place like Reunion Island, which is actually on the equator, and there is nothing on the east coast until maybe Australia, or right. So it's very easy to launch from there. That is one possibility. The second possibility is we can also take a barge, sail to the equator and launch from there. So those are all ideas that we have. In fact, we have ideas of like going to go on a barge and then release a balloon to take a rocket and then launch from this. All of these possible.
Okay, sir.
And many of these things are made possible because we are actually doing small, right? When you do things small, right? Again, the infrastructure, thing, right? A lot of things become possible, which are not possible when you try to do things large. Yeah.
Well, actually, in your PPT, you stated at one place that Agnibaan will be using like 1 by 30th the cost and 1 by 4th the size of the SpaceX Falcon. So,
Yeah.
like reducing the size or the cost, do you think there will be many demerits of there must be some disadvantages of reducing the size or the cost?
So we are not really aspiring to do. So there is there is an economic principle that's that's at play over here. So there is a book by a person called Clayton Christensen, and the title of the book is The Innovator's Dilemma. So whenever you are actually coming up with a new technology, and in this case, the technology here is a fully 3D printed rocket, right? And then so we now size our 3D printed rocket to what is maximum that is buildable by a 3D printer today. And we now say, okay, how many of these rockets that we have to cluster together not to make a bare minimum launch vehicle? We can't have like about 100 of those, right? That will make it more complicated, right? What is a bare minimum that is doable And then we now say, okay, 7 can be done. That gives you 140 kilonewtons, and we can launch a 100 kg up to 100 kg. So all of these things, right? So when a new technology comes, usually it is inferior to the current level. The current level is, let's say, SpaceX. Okay. So what we do is we now completely enter a new market of small satellites, which SpaceX will find very difficult to offer, because for them, if they have to use small satellites, we'll have to make the small satellites weight, right? And then they will have to cluster a large number of those small satellites, and all of them will actually go only to one orbit, right? So if you have to have money multiple, so they face that problem. So what will SpaceX do? They will actually concentrate more and more on larger satellites, or taking people to the space station, or going to Mars and put a car there, no, all of that. So those kinds of big things, right? So as we grow, we will actually grow our launch vehicle from what it is today. And the last slide I showed, we could actually put strap-ons for the same configuration. Now, if the build volume of the 3D printer becomes bigger, we will actually start making bigger rockets and then cluster them. So our 140 kilonewtons will actually become much bigger, right? So the first stage launch capability becomes much bigger, and then we can now get into the SpaceX class. But by then, we would actually be the cheapest for any satellite, right? And then all of them will actually come to me, and SpaceX will only be able to do humans and cars to Mars. That sounds very rhyming, right? So right, they will actually be edged up, and therefore they will get edged out. This is how old companies get replaced by new companies. New companies come up with a disruptive technology which gives an inferior performance than the current technology. So the current technology guy is busy making money in what he is making, because it's a big market that he is after. He cannot afford to do these small things, and we will actually end up doing small things and then grow from there, and we will edge that guy out. So this is a economic principle that Clayton Christensen has laid out. And that's exactly the path that we will be following.
Yes, sir. Small things, big changes.
Yes.
So,
Okay,
sir,
sir.
actually,
So I'll be asking the last question. So, sir, as you said, you are trying to enter the small satellite market. Sir, there are already competitors like Rocket Lab, which has already many orbital flights. Then there is Skyroot, Bellatrix, and even ISRO is developing their own small satellite launch vehicle, SSLV. So, do you think they will pose a strong competition or a threat to Agnikul?
Yeah, definitely. I think that's the reason why I think there was one slide that showed what is how we hold up against key competitors, about some 3 or 4 competitors that, I mean, not exactly the ones that you mentioned, but including ones that you mentioned. But the quick answer is Google was not the first search engine, right? So if you come up with a really good search engine, right, you can be Google, right, or you can beat Google, right? So this is very important. Technological merit translating to an economic merit, right? Solving clearly addressing customers' pain point. So if you have all these principles in place, it doesn't matter that somebody has actually been doing things already so far, or similar things are being done by other people and so on. Right. So you have to ask the question, okay, are these guys actually also doing the same technology, or are they having different technology, different scales, and what are their pain points, and all of that. So if we are slightly different from other people, and we are able to offer the advantages to customers better than them, we will prevail. It's a very simple economic principle, but founded on technological advancement. Right.
so yes, sir. I'll be asking some general questions to you, like for the youth, related to the inspiration and all. So, what was the motivation behind you choosing this field, like becoming a scientist and doing all this research and all?
Oh, I mean, sorry to disappoint you. It is totally random.
Okay, sir. So you have been the founder, co-founder, and head
So
of.
the only thing that stands out, if you uh, people basically go where life takes them, right? So JEE is a lucky dip. If you are able to crack JEE and you get a particular rank, you get slotted in one particular branch, and so on. There are a lot of people who have actually got out of the branch that they did and did something else and then made big. I am one of those guys. It seems like in hindsight, about 50 years of life, I can probably get enough data points to say that I'm more like this Forrest Gump kind of character, if you have seen that movie from the 90s. So if you take up one thing, do that properly. That's the thing that I have been doing. So excellence is now kind of like second nature. If I take up something, we always have to look at what is the world standard on this and how do we reach that world standard and excel past that world standard and become the world standard. So so anything that we do, if we are able to think like that, we can make an impact. That is the only thing that I have been following.
So, sir, you have been the founder, co-founder, and head to many of the institutions, and you have also probably visited many of the other organizations. So, I deeply believe that behind all these establishments, you must be having one of the ultimate goal, like ultimate goal in your life. So, what is it? We'll love to hear that.
I don't know. I mean, that's actually very, very difficult to say. No, I mean, no. At different points in life, we have like different goals that are reachable. Like for example, when I was doing my PhD, my goal was to become an IIT professor, right? So, and then once I became an IIT professor, I have to now say, okay, what next I have to do? So then I actually set up the NCCRD, which is like the world's largest combustion center. So once we did that, we now are actually into entrepreneurship. It's only in the last year that I have been able to synthesize all these different startups that I'm in to see that there is a common recurring theme of defrastructure by necessity. Because if I'm actually trying to, for example, Aerostrovilos is making a gas turbine engine for power generation, very much like what GE or Siemens and have been doing at the hundreds of megawatt scale. But these guys are trying to do 100 kilowatt level, right? So when you start up as a company pushing the technology that you're developing in the lab, you can't suddenly become a GE. You cannot suddenly become a Siemens, right? So you can do only small things. So what is possible with the small things? What impact we can do? Like I said, the infrastructure. We don't need these large things. We can actually do the same impact with large number of small things, right? So when I did that, then we found that we were always doing small rockets, small satellites, small engines, small planes. Everything is small, right? So is it possible to actually do things small and grow big, right? So that is the current recurrent theme that has given rise to this infrastructure. So I would say that in the next 10 years, maybe I will espouse this and like evangelize this. That's what. And then the other thing is like, beyond about 50, right? You stop thinking about making impact to yourself. It's more important to enthuse and motivate guys like you to make the next impact. Right? Yeah.
So, sir, then I'll end up with the last question. So, you being a very successfully established scientist, so we'd love to hear your message for the future of India.
Oh, I think India is a very funny country. Uh, okay. I see two things about India. One is India, and the other one is Indians. Okay. So the reason why I'm saying that is a large number of Indians have been extremely successful outside of India, right? So we have to actually start looking at Indians making India and not India making Indians. If you now look at America, it's America that is making Americans. Okay, because America is considered to be great. Everybody assumes it's great, right? And we have now found recently a lot of evidence to the contrary, right? But still, people will say, "Hey, come on, America is great," and all that, right? So Americans are actually made by America, whereas in India it's actually the other way. Indians are the ones that actually make India. So if and I think we have come to a point today where there is a huge strength for Indians to stay in India and achieve what they have to achieve rather than go outside and achieve that, right? Because there is a lot of strength in actually doing things from India. All right. So I think from India for the world is actually a very good approach that you can think about, like what Agnikul themselves are trying to do. Is it possible for us to develop technology from India with which we can push that out into the world and get other people to also take up our technologies and so on? That's important. That said, I think one of the messages that I've always been trying to do for young people is something that you have to clearly understand. It is now within your lifetime's reach that we will actually become the second largest economy in the world, and we'll beat the US. Right? This is regardless. This is actually a ongoing story for the last 20 years. right? And this is despite how many people have gone abroad and settled abroad and all of this. So, like, let's say any of you actually go abroad, maybe you are a loser, right? Because in your lifetime, you will actually see that India becomes the second largest economy in the world. All right. And by the turn of the century, which is like maybe further past your lifetimes, right, in your next generation's lifetimes, it's very likely that India will become the largest economy in the world, surpassing even China, right? And that is because for thousands of years, India has been the largest economy in the world and a significantly large economy in the world until about 100 years back. Okay, so up to 200 years back, it just suddenly plummeted because of this British rule and all of those things, and it's been coming up again, right? And in this century, it's coming all the way up to second, third, and that kind of thing, and then it's actually going to go up again. Now, economists can't even predict like a recession that's going to happen next year. They will get the Nobel Prizes and all, but still, economics is not like a theory that can predict what will happen over thousands of years. So what I would say is India being actually the topmost country in the world has been a natural law until this looked like some kind of some BJP nationalist kind of thing, but just look at the hard data, right? So you don't have to actually have any political affiliations or anything. Just look at the hard data. It's kind of like a natural law that India has been at the top, and then they had a sudden small blip of about 200 years when they actually fell down, and then they are actually coming back again, right? So the mindset that we need to inculcate among ourselves is India is supposed to be at the top, and we are supposed to be global players. We should actually be playing at the top of the field. That should be our mentality. Right. Once we actually cultivate that mentality, we'll automatically get there. Right. It's kind of like a self-fulfilling prophecy. Right. And that conviction is something that you guys will have to inculcate in your generation. That's very important.
Thank you so much, sir. Really loved your message. Like what you said that India should not make Indians, but Indians should make India. So thank you very much for spending your time with us, and I think we really learned loads of things from you today. Thank you so
Yeah.
much once again.
Thank you. My pleasure talking to you people. Very nice. Bye-bye.
अप्रैल में होने वाली नासा ह्यूमन एक्सप्लोरेशन रोवर चैलेंज 2021 में भाग लेने के लिए ओडिशा के नवोन्मेष प्रसाद स्टूडेंट एस्ट्रोनॉमी टीम यानी कि नैपसैट के 10 स्कूली छात्रों को चुना गया है। आपको बता दें कि नवोन्मेष प्रसार फाउंडेशन की एक पहल नैपसैट जो कि भुवनेश्वर में है। नैपसैट अंतरिक्ष में रुचि रखने वाले लोगों की एक टीम है जो विभिन्न अंतर्राष्ट्रीय कार्यक्रमों में भाग लेने के लिए अंतरिक्ष प्रणालियों, रोवर्स, रॉकेट्स, उपग्रह और खगोल विज्ञान के डिजाइन को समझने और जानने में लगे हुए हैं। आइए नवोन्मेष प्रसार फाउंडेशन के फाउंडर अनिल प्रधान से ही समझते हैं कि नासा ह्यूमन एक्सप्लोरेशन रोवर चैलेंज 2021 क्या है, इसमें किन स्टूडेंट्स को चुना गया है और ये स्टूडेंट्स नासा के इस चैलेंज में क्या करने वाले हैं।
तो सबसे जो सुखद बात है इस समय का वो ये है कि भारत में पहली बार किसी स्कूल स्टूडेंट्स का एक टीम है जिनको नासा रोवर चैलेंज के लिए सिलेक्ट किया गया है। तो ये एक टीम हम लोगों ने क्रिएट किया वर्चुअली। अभी जस्ट जब कोविड टाइम आ गया, जब ज़्यादा मूव लोग नहीं हो पा रहे थे, उस समय में 10 ऐसे बच्चों को हम लोगों ने निकाला पूरे उड़ीसा में से जो टेक्निकली बहुत साउंड थे, जो कुछ और करना चाहते थे, तो जो देश के लिए कुछ करना चाहते थे। तो वैसे हम लोगों ने 10 बच्चों को पूरे उड़ीसा से निकाला। फिर हम लोगों ने उनको बहुत सारा ट्रेनिंग दिया और फिर हम लोगों ने अप्लाई किया नासा रोवर चैलेंज के लिए। सो पहली बार के लिए ऐसा हुआ है हिस्ट्री में कि एक ऐसा टीम जो उड़ीसा में है वो सिलेक्ट हुआ है नासा रोवर चैलेंज के लिए। और ये एक ऐसा इंटरडिसिप्लिनरी टीम है जिसमें स्कूल स्टूडेंट्स ही नहीं, ITI के स्टूडेंट्स भी हमारे साथ हैं। और ये लोग बनाने वाले हैं एक ह्यूमन रोवर, एक ऐसा रोवर जो मार्स की सतह पर चल सकता है, लेकिन ये पूरा ह्यूमन पावर्ड रोवर रहेगा। तो ये जो चैलेंज है, हम लोग को इनविटेशन आया है नासा से, और ये जो चैलेंज है ये अप्रैल 2021 को होने वाला है। तो इस चैलेंज के लिए बच्चे अभी से ही नेक्स्ट 4-5 महीने में एक रोवर बनाएंगे और उसको फिर हम लोग ट्रांसपोर्ट करेंगे नासा को, और फिर वहाँ पे जाके हम लोग अदर टीम्स के साथ जो अक्रॉस दी वर्ल्ड हैं उनके साथ हम लोग कॉम्पीट करेंगे और इंडिया को वहाँ पर रिप्रेजेंट करेंगे। ये स्कूल स्टूडेंट का पहला टीम है जो इंडिया से गया है। और उड़ीसा का पहला ऐसा टीम है जो इसको रिप्रेजेंट करने वाला है नासा में। 10 बच्चे हमारे पास, सब दूसरे दूसरे बैकग्राउंड से हैं। कोई अभी स्कूल में पढ़ रहा है तो कोई अभी ITI स्टूडेंट है, कोई भुवनेश्वर से है तो कोई मलकानगिरी से है, तो ऐसे अन्य अन्य जगहों से आए हैं और सबकी अपनी अपनी स्पेशलिटी है। कोई गाड़ी के कोई रोवर के चेसिस पे काम कर रहा है, तो कोई सस्पेंशन पे काम कर रहा है, तो कोई ब्रेक्स पे काम कर रहा है। तो अभी जस्ट हमको ये चीज़ पता चला है कि हम लोग सिलेक्ट हुए हैं, 6 तारीख को ही पता चला जब हम लोगों ने अपने रिपोर्ट्स को सबमिट किया था नासा को। हमारा रिपोर्ट बहुत अच्छा लगा और उन लोगों ने बोला इस टाइप का रोवर बिल्कुल बनना चाहिए। तो 6 तारीख को पता चला है और अभी से हम लोग फंड रेजिंग भी शुरू कर रहे हैं इस चीज़ के लिए। तो हम लोग कॉर्पोरेट्स और इंडिविजुअल से यही रिक्वेस्ट करेंगे कि हमको सपोर्ट कीजिए, सो दैट हम इस रोवर को बना के नासा को लेके जाए और इंडिया को रिप्रेजेंट करें। सिर्फ रिप्रेजेंट ही नहीं करें, वहाँ से जीत के भी वापस आएँ, जिसका तो ये चैलेंज हर बार होता है। और जो भी विनिंग टीम होती है इनको अलग अलग सेक्टर्स में अवार्ड्स दिया जाता है और प्राइज़ मनी भी दिया जाता है। तो हम लोग हर सेक्टर के लिए कॉम्पीट करेंगे और चाहेंगे कि देश के लिए हम लोग एक अवार्ड लेके आएँ।
आइए सेलेक्ट हुए स्टूडेंट से ही जानते हैं कि नासा के इस चैलेंज के लिए सिलेक्ट होने पर उनका क्या कहना है।
So what happened was that I knew about napsat like while I was browsing about astronomy and stuff, and I was really interested like what they were doing and all the undergoing projects in like under napsil and napsat. So I was really interested and I decided to try out for this team napsat, and fortunately I got selected among the 800 students who applied for this. So we got selected for the NASA Human Exploration Rover Challenge 2021. We are the first team from Odisha to get selected and the first high school student team from India, because like there are 2 categories. One is from like 14 years to 19 years and another one is college division. We are the first one to get selected in the high school category. So we are going to go to Huntsville, Alabama in April 2021 and we are going to represent India over there in this competition.
सो मैं वैसे ही मतलब मुझे एस्ट्रोनॉमी और चीज़ें लाइक बनाने में ये सब बहुत इंटरेस्टेड था। तो मैं ऐसे एक दिन गूगल में सर्च कर रहा था और बहुत सारे रिसर्च पेपर्स ढूंढ रहा था। तो वहाँ पे मतलब मुझे इनका नवोमेश नैपसैट का साइट मिला। तो मैंने देखा ये लोग ऐसे कंपटीशन कर रहे हैं, मुझे लाइक बहुत इंटरेस्ट है ये सब चीज़ में। तो मैंने अप्लाई किया, फिर हमारा टीम सिलेक्शन हुआ, हमने काम किया इस चीज़ पे। फिर हमने रिपोर्ट भेजा नासा को और 6 तारीख को हमको फिर गुड न्यूज़ मिला हम कि मतलब हम लोग सिलेक्ट हो गए। तो फिलहाल तो वही है। तो ये जो है ये एक ह्यूमन पावर्ड रोवर है, मतलब इसको हम ह्यूमंस चलाएंगे। जैसे हम साइकिल चलाते हैं पैडल से, वैसे इसमें भी मतलब पैडल्स होंगे, हमको वो पैडल से चलाना है। बस इसमें डिफरेंस क्या है, ये 4 व्हीलर है और इसको मतलब 2 लोग मिलके चलाएंगे। नहीं, रोड में तो नहीं, ये हम लोग बना रहे हैं इसको मतलब मून में, मार्स में जो टेरेंस होते हैं वहाँ पे चलने के लिए बना रहे हैं। तो वहाँ का टेरेंस जो स्मूथ ही नहीं, यहाँ पे छोटे छोटे मतलब गड्ढे होते हैं, बोल्डर्स होते हैं। तो उसको संभालने के लिए हमको एक मेन फ्रेम डिज़ाइन करना पड़ा, हमको भी सस्पेंशन में भी बहुत सारे चेंजेस करने पड़े। सो लाइक हमें उसको इतना स्ट्रॉन्ग बनाना था कि 2 लोग का वेट भी उठा सके और साथ ही मतलब इतना इजी भी हो चलाने के लिए, ज़्यादा मुश्किल ना हो, बहुत मतलब ज़्यादा स्टिफ नहीं होना चाहिए, स्टीयरिंग आसानी से चलना चाहिए। और मतलब फिलहाल तो वही है। इसको हम अर्थ पे टेस्ट करेंगे, अगर मतलब सब कुछ टेस्ट करेंगे, अगर सब ठीक ठाक हुआ तो ज़रूर ये मतलब मून में जाएगा। नासा का जो एक मिशन था अपोलो मिशन, जो कि पहला मैन था मतलब मून में गए थे, जो उसी का ही सेकंड पार्ट होगा आर्टेमिस, जो कि 2024 में एम किए हैं। तो उसी के लिए हम लोग अभी रोवर बना रहे हैं। तो इसका क्या होगा, हम मतलब वर्ल्ड में जितने भी है टोटल 100 टीम्स है, सारे अपना अपना डिज़ाइन लेके नासा में जाएंगे, हम लोग कम्पीट करेंगे, रेस करेंगे और उसी बेसिस पे नासा अपना एक मतलब रोवर बनाएगा या फिर हमसे डिज़ाइन लेगा, हमारा डिज़ाइन